Hello, here's a quick video tutorial about how to make a slightly bipolar nebula with some um, high density regions in the polar sections of the nebula. Okay, here's the interface. So let's start with a new project and go to the 3D module. This is the newest version of the module. It looks a little bit different and is handled slightly differently. Usually we had some control buttons up here, but now we click on the right and you can choose the cameras. Render view, we also have a new preview here, which allows you to look at the density distribution as a volumetric rendering. I'll show this in a minute. And here's the properties tab and the maximize tab, where you can make it full screen each of these views, and you go back by right clicking and restore with left click. Okay, so we start with a sphere. Let's say if you want to do something more physical in the end, let's first go to the render module and set up the size of the view correctly. Say if there's something very large, then let's start right away with an image size of 10 to the 16, say. And then start with a spherical object. Click on the primitive, then click on the view and drag it out. Let's check that the size is correct. This is too small. Actually, this view is very small still, so we have to we best delete this and start again here. First we reset these. We select each of these windows and click on reset. Then it will match the size of the render view, which should be correct already. If we now make our sphere, we'll see that the size is already of the same order of magnitude as the image size that we just put in the render module. Okay, now let's make this something round number. Okay, now we have our sphere. We want to make this slightly elliptical. We go to the modifiers and add a size modifier. And extend the z-axis slightly. Now what we're going to do is to make a copy of this. Say this is the elliptical. Change the color. This color is too dark. And copy that by clicking on this copy button. This makes one copy of the object. Initially the names don't match here. You just click around once and it updates. Let's say this is going to be one of the ANSI, let's call that's a name. Let's call it polar density. I don't know. And call it 1, because we're going to make 2 of them. Change color so we can clearly see the difference. Or let's keep this one red to make this the red shifted one. So we make the original elliptical something neutral like green. And this one's going to be the red one. Okay, what we're going to do now is go to the primitive. First of all, set a minimum radius, slightly smaller, so we get a shell. And now we're going to change one of the angles here, which opens the object and makes it a small region. right? Something like this. You can change these parameters according to your needs. So you get a higher, you can select a higher density region in at the tips of the poles. Now you're going to copy that one, change the name again. This is number 2. We make this one blue. And now we are going to rotate that. We have several ways of doing this. Or we can, no, forget it. We're going to also do the primitive thing. Exactly the same, just the other way. So they're the same, but in opposite directions. Now what we do is say change the density by some factor, say 3. Same for the other one. Okay, we have to give the elliptical still some thickness. Go to the primitive, set another shell thickness which may be smaller than the other one. Like that. For setting shells, you can also use the shell modifier, which has a bit more sophistication because you can change the shell thickness depending on the distance or so, on the position. Here's the shell modifier. But for this purpose, this is good enough. And now you want it, if you want a torus, there are several options. You can either use the density distribution of the ellipsoid itself. Let's try that first. You edit the magnitude. And here you go from quick mode to custom mode. Keep spherical coordinates. Go to the phi angle, which is the latitude. 90 degrees is the equator. And we are going to use points to define the density distribution. We right click somewhere on the graph and then click on add point. We're going to do this several times. Here around the equator, and then at the end point, we click on the point. If we click on the point, with right click on the point, we can choose set point and then put in exact values. We're going to set this to 1, and the lower value, same thing, right click, set point, set this to 0 angle and set this to 1. And now we're going to set the middle one to exactly 90, so it's on the equator, and say 5 times the original density. And the other ones we're going to set somewhere else. Set to 1. That should be 70. Okay. Now we can, if we want, we can smooth this out by clicking on this little button. And now we get little handles on here. If we control click on this, we can drag them out. Remember, this has to be control. The left one is first and then the right one. Okay, now we should have high density on the equator and lower density, uniform density everywhere else. Right, we are ready to render. We could first change the orientation, choose orbit here and change the orientation of the render view. Okay, the red one, the red pole is on the far side. Let's make it close to the edge on view. Go to render view, camera, and set exactly, say, 90 degrees. This has turned them around, but now we're perpendicular to the line of sight. Okay, and now we can just click on render and get our bipolar elliptical nebula with our torus and our polar regions. Now if you want to make the polar regions smooth density distribution just like here, so then you can do something similar. You go to the density modifier, go to the magnitude, choose custom, and you go here and set your analytic. Go to the point distribution. Now we can say start at 5, go down to 1, go down to 0 at some 25 degrees or so if you want. Set this precisely to 0. Okay, choose again this button, control move the first one away, do something like that, and then you get a smooth transition here. Okay, you could of course skip these altogether, delete these, don't delete these, disable them by making them invisible, and use the elliptical shape. Go to the modifiers, density, and add another point here. Drag this up. So you can, of course, they don't have to be exactly the same. And then render. Now the density enhancement is in the same shell. Now if you want to give these different properties, then this will be more trickier than using the different objects, separated objects, right? Now let's give them a velocity. We add a velocity modifier. Let's see what we have. It's a default linear velocity radial vector field. We have to change reference distance to 1e16 or something like that, and we set this to 1, so at the edge of the image it's 1, and then we multiply it by whatever we want at that distance, say 200 kilometers per second. Let's make this 400. And now we adjust in the group tab here, we select our group up here, our image group, and adjust the slit size to a height of 2 times 10 to the 16 and 2 times 10 to the 15 width. So we have a decent size here. Now we can generate a PV diagram. We render this and the PV diagram shows up here. We can increase the range of the velocities here. Control S will re-render. It's like clicking on the button. Okay, now you have your PV diagram. If you incline the camera at some arbitrary value, you will have a different shape of the PV diagram. Now you wanted to see the graphs, if you want to see the graphs, we click on the graph module, select the connected graph, go to type PV. Now you have your PV diagram basically, or your line profile, which is rather noisy. We can, why is that? Because we have these little stripes here. There's aliasing in this image because we have a different grid size to the image size. For example, we set the grid size to the same value, or let's make them both smaller so it's faster. This doesn't need much resolution, so this still has this aliasing. We then go to the group and set a resolution for the velocity, say 20 kilometers per second, so it goes away. We also set a resolution in the image tab for the seeing, which could be, I don't know, in times e to the 5e to 14. Okay, so we have some smoothing here. Now the PV diagram or the line profile will be smoothed as well. Okay, so you have your light profile. If you now change the orientation, camera, something like that, say. Okay, now let's change the range of the group further. Okay, something like that. Now you should see separate peaks for these bright regions in the graph. Here they are, 4 peaks. Okay, that's basically what you need, or you were asking for. And there you go. I will upload this file now.